Okay, so when you talk about data types and then values, what kind of values we can have? So example, if you talk about this 9 or this 8, these things are actually called literals because they are literally the values, right? So what we can do is we can play with some literals here. Let's work with integers first and we'll come back to this. So we are basically working with literals now. Okay. Now what kind of literals we can have? For example, we can have direct values. We have 9 here. And we can have any big value provided that goes into the range. So whatever range we have, it's a part of the range, it will work. So we have all these are decimal values, right? So it will have a base 10. What if you want to work with base 2? Something like a binary format. Can we do this? Let's try. So I will say 0B101. So basically, if you want to put a binary number like 101, which is 5, so you can put B and then you can put a 0. Let me just try if this works. I will say system.out.println. And then let me print num1. Let's see if this works. Put a semicolon at the end. Compile. There's no issue. So let's run this code and let's see what's the output. And you can see we got 5. So yeah, that's the binary format works. What if you want to work with hexadecimal numbers? In this case, you can use X here. And let's put a number. 7E. So E also supported, right? So let me just try, compile, run. And you can see we got 126. I don't even know if that's the correct answer, but you can verify. There's one more thing which we introduce later in Java, which is what if you have, let's say, this number? And trust me, I always get confused with number of zeros in any amount. Even if I mention a password or a PIN or account number, and whenever you have multiple zeros, I always get confused. So how do you count the number of zeros here? Of course, you can do it one by one. But in Java, we got this feature where you can put an underscore between numbers. If you want to differentiate them, it was easy to count, right? So you can see we are getting zeros and then we got underscore. Even this works. Let's try it out. Compile, run, and you can see we got the output. Of course, in the output, it will give you a normal number. But as a programmer, it helps you for the number of zeros you're entering there. So these are basically literals, right? Let's try with float this time. So let's say this is float and we are saying num1 and then I want to assign a very different value. Can I assign, no, let's go with double just so that I can avoid that F at the end. And here I want to assign, let's say 56. So basically when you try to assign an integer value to float, it will work, or double, it will work because integer will get converted into double automatically. When you save it, okay? Okay, that makes sense. Can I have different value? Let's say I want to store a very big number. So I can actually use epsilon e in between. I can say 10, 12 e raised to 10. And let's see if that works. Compile, run. And you can see we got the value as well here. And it will adjust automatically based on its own implementation. So it is assigning 1, 0 here. So there's basically 12 into 10 raised to 10 or 12 into 10 into 10 raised to 10. And then it will adjust its according to its own way. And we have already discussed about the Boolean. It is only true and false. There is no 1 and 0 there. Don't try to assign 1. It will give you error. Let's try. Compile. Okay, you can see we got the error. It says int cannot be converted to Boolean. Remove this. Okay, how about character? Let's try. So when I say character, let's just see, and I want to assign a character here, which is in single quote, let's say A. Now, when you try to print the character, this will work. Compile and run. You can see we got A. Now, basically, character can be also treated as integer. That's right. We can actually perform operations. So I can say C is equal to C plus 1. So what I'm doing is I'm incrementing C. I'm enhancing the value of it. If it is a normal value, it's a 5, it will become 6. Okay, what if you want to do an increment? Of course, we'll discuss this later, what increment means, but you can say plus plus to increment the value. And if you try that with character, compile, you can see that it is getting compiled. And if I try to run this code, we got A, because we are printing it there. My bad, I would just have to put that here. So first we have to increment the value, then we can print it. So C++ simply means we are changing the value. Okay, this is not a language I'm talking about, the operation on a C variable. And you can see we got B. So when you increment the value of A, it becomes C. It becomes B. Cool. So basically all these things are called literals. In fact, there's a concept of string literals as well, where example, when you talked about hello world, that's a string, that's string literal.